I'd like to go over a couple of things with basically part two of section 6.3, running along with the sum and difference identities that we talked about yesterday in class. Some of these I actually already started working out. In fact, these two that you see on the screen are already worked out. So what you might want to do is pause this and then write down what you see, and then I can explain some things so that you're not writing and talking at the same time. Totally up to you what you want to do. So what I did here, we were supposed to find the exact values of these expressions. Now this looks a bit interesting. It's sine of 63 times the cosine of 27 plus the cosine of 63 times the sine of 27. And you may look at that and say, I don't know what's going on with my life. However, if you look at that, look at your formula sheets, and that is just like the one that says, look at the formulas there, sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So this is basically a formula for the sine of 63 plus 27. In other words, the sine of alpha plus beta. So if alpha is 63, beta is 27, if you add those two together, that gives you 90 degrees. So you can say that this whole formula is a formula for the sine of 90 degrees. And then you can just think about what the sine of 90 degrees is, and that is 1. So our answer here is 1. For the second one, and so basically it's kind of like working backwards from what we did yesterday. This second one says the sine of 43 times the cosine of 13 minus the cosine of 43 times the sine of 13. Well, that is another one for sine. In fact, these difference identity for sine, which says the sine of alpha minus beta is equal to sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So this is a formula for the sine of 43 minus 13. Well, if you take 43 minus 13, that is 30. So if you think about it in the unit circle, the sine of 30 degrees is 1/2. Therefore, the answer here is 1/2. A second situation, and this will be our last one, is take a look here. It may look kind of familiar. We're given that the cosine of alpha is negative 12/13, where alpha is in the second quadrant. We're given that the sine of beta is 8/17, where beta is in the second quadrant. We're supposed to find the sine of alpha minus beta. So what I've done is I kind of wrote down some information. We're given something about alpha, and we're given something about beta. What we're given with alpha is that the cosine is negative 12/13. Well, if you think back to what we did from the beginning of the trig this year, cosine we labeled as the x value over the r value. So if the cosine of alpha, here with alpha, the x value must be 12 and the r value must be 13. If you go ahead, what we can do is we can actually find what that y value is by using the Pythagorean theorem. It's even a Pythagorean triple. What you will get for y is 5. Now, we're also told that alpha is in quadrant 2. So if this is in the second quadrant, the y value is positive there. The x is negative and the y value is positive. So these are my values for alpha. For beta, we're told that the sine of beta is 8/17. So if that's the sine, that means this is the y value and this is the r value. So the y value is 8 and the r value is 17, which leaves us with 15 for x. Now this is also, beta is also in the second quadrant, which by the way, the angles aren't always in the same quadrants. But in this case, beta is also in the second quadrant. Therefore, the x value must be negative over there. The reason I needed that information is if I'm going to find the sine of alpha minus beta, well, I follow this formula that goes along with your formula sheet. Sine of alpha times the cosine of beta minus cosine of alpha times the sine of beta. And I can fill in that information. The sine of alpha is 5/13. So I've got 5/13 here. The cosine of beta will be negative 15/17. So I get negative 15/17. I'm going to subtract the cosine of alpha, which is negative 12/13. and times the sine of beta, which would be 8 over 17. Okay, so if I combine these, if I take 5 times negative 15, that's negative 75. 13 times 17, I believe, is 221. Over here, I'm subtracting a negative 12 times 8, which is 96, so I'm going to call that plus 96 over 221, in which case I can just go ahead and combine those two together where I get 21 over 221. That actually does not simplify. So my answer is right here. Hope that makes sense. If it does not, you might want to kind of rewind and go back to any of that you need to. Also, you can talk to each other and see if it makes sense with each other. All right, thanks a lot.